This video is going to cover the topic of unit rate, but we're going to specifically talk about this essential question: what are some ways that we apply and use unit rate? Let me first define rates, and we've been working with ratios a lot. Rates are a specific type of ratio that compare two different units. For example, if we have a ratio of hours and miles, that would be a rate, right? Hours is one unit and miles is another. If I talk about Amelia, who loves to read, and I say that Amelia reads 4 books in 7 days, I could write that as a rate, right? I could compare books to days, a ratio comparing the number of books to the number of days it takes. And one way I could represent that rate is using a tape diagram. A tape diagram looks something like this. I have 2 bars that are equally long, and the books, labeled with B, are cut into 4 sections, while the days are cut into 7 sections. And right here, we know that 4 books are read over the course of 7 days. I know that if I draw the same pair again, I'd be able to say, well, she then can read 8 books in 14 days, right? And it can show me that rate growing. And I could keep this going, right, as long and as far as I needed to help me interpret the rate. It's similar to a ratio table, which we've worked with before, but it's just a different visual. And we like to provide different options for folks who might like one visual over the other. Of course, if I wanted to figure out how many books Amelia could read in 21 days, I could also set up a ratio in fraction form. And I could say, well, I'm trying to get to 21 days. And I know that I have to multiply that by 3. It's 3 times as long. And so I'll multiply my number of books by 3. And then my answer would, of course, be 12 books, right? So that's another way to look at it. Sometimes you'll also see or want to use tape diagrams to help you find the unit rate. And just a quick reminder that a unit rate is a ratio where one of the values is 1. And when we write it in fraction form, that denominator is what we look for as 1. We'll take a look at this example of being able to run 8 miles in 2 hours. I've set up the tape diagram to have 2 bars, right? 2 pieces of tape, essentially. One for our 8 miles and the other for our 2 hours. And I'm going to divide those up into pieces. I've broken the miles up into 8 pieces. I'm going to go ahead and break my hours up into 2. And since I'm looking for a unit rate, I'm looking for 1 hour's worth of distance, right? So I can look right here, and that's 1 hour, and it corresponds with the section here, which is 4 miles. And the other hour corresponds with 4 more miles, which of course means that our unit rate is 4 miles per hour, or for 1 hour. And we probably could have done this no problem as well without a tape diagram, because I could have done this up here where I said, well, I know I need to divide 2 by itself to make 1. So I'm going to divide my numerator by the same thing, right? And that would of course gotten us 4 miles as well. But it's good to have options when the numbers maybe aren't so friendly, or because so many of us might be visual learners, right? So it's just good to see different ways to approach the same problem. I use unit rates the most in my life when I'm trying to compare prices at the grocery store and I'm trying to figure out which is the better deal per ounce. This time I'm not going to use the tape diagram. I'm just going to set these up as ratios, and I'm going to look at a price that shows me I can get for 5 ounces, I can pay $3.75. Or for 4 ounces of the same product, it would cost me $3.16. So I need to find out the price for each ounce so I can compare them. Which means for my top choice, I need to divide this by 5 for numerator and denominator. And for my bottom choice, I'll need to divide by 4 for numerator and denominator, and that will give me my unit price. When I do that long division, I find out that this option costs 75 cents for 1 ounce, whereas the bottom option costs 79 cents for 1 ounce. That's not a big difference, but the 5 ounce option is about, or exactly, 4 cents cheaper than the other. So it's a better deal. We can also use and apply unit rates when we're trying to find out more information than just the unit rate itself. So if George and Georgina are going 351 miles and stop 3 times, we could use a rate of miles per stop to figure out how far they would travel if they stop 5 times. This is multi-step, so the first step is to find the unit rate, which means we need to know how far they went every time they took 1 stop. So I'll divide this by 3 and do the same to the numerator. And 351, if I take a moment to answer that, ends up being 117 miles per stop. And then that leads me to step 2, where if it's 117 miles and they stopped once, if I want to know how much distance they would cover after they do 5 stops, right, I would scale this up. So I'd say, well, this is 5 times as many stops. So I'm going to do the same thing to my numerator and calculate 5 times as many miles. And 117 times 5 happens to be 585 miles. So we know that would be our final answer. If they stopped 5 times, it's because they went 585 miles. I first found the unit rate and then scaled that up. For your turn, I want you to try applying these strategies. And I'm going to let you know that I can buy 6 books for $18 at a sale, maybe the Friends of the Library sale. And I want to use that unit rate per book to calculate the price that I would pay for 10 books. So my first suggestion would be to find the unit rate per book and then use that unit rate that you get per 1 book and scale it up to find the price for all 10 books. And we'll talk about this and process this question together, but I want you to try it yourself first. Many of us are forgetting to try this first, so make sure you try that. And remember that the question we went into this with was, how do we use and apply unit rates? And we've seen that we use it for comparisons and we use it to scale up to find different values. And we'll find out that there are even more ways that we use unit rate going forward.